Mark P. Otten back with you. Okay, welcome to your confirmatory factor analysis, or CFA, instructional video for how to get one, how to do one in R. Here is your code, which I will be explaining here in a second. I've done a couple of things up front. One is I imported a data set already from SPSS into R, called it Factor Analysis 1. And it is 9 items from the Competitive State Anxiety Inventory, CSAI. And those 9 items are the items depicted here in the diagram. And hypothesized are 3 factors: somatic anxiety with 3 indicators or components, cognitive anxiety, and self-confidence. So those are your, so I've got the numbers here already in the diagram. Now I'm going to show you where they came from, how to get them in R. I have also selected the Levon package, or the supplement to R over here. So we're getting used to doing that automatically to run latent variable analyses. And here's the code again. So you can call it anything you want. You can call your model whatever you'd like. I have called it ottengolf.model. I have called it that because, well, when I play golf, I experience competitive state anxiety, somatic, cognitive, and occasionally, if I'm lucky, self-confidence, maybe once in a while. So anyway, so I've called it that. You can call your model whatever you'd like, but you need to call it something .model. That's where the R code needs to be specific. And then here, we've got the 3 factors specified. So the key to that is to put an apostrophe before the beginning of the equations, and then one at the end as well. And then, so to specify a factor, instead of, so like for regression, we just used a tilde, like the capital character next to the 1 on your keyboard, the squiggly line, the tilde. Now we have, whatever you want to call it, now we have equals tilde to designate the fact that these variables are composing factors. They're not going into regressions. So for example, the somatic, you can call this, again, you can call this whatever you want for the first factor. You can call it factor 1 if you want to keep it simple. So for somatic, that one is composed of 3 items, item 1, item 4, and item 6. So those are laid out with plus signs in between them on the right, and then in between is the equals tilde to designate a latent variable. So this is telling R, hey, I've got a latent variable here. Same thing for cognitive anxiety in the next line, and for confidence in the last line. The variables are laid out there according to what they're called in the data set. And then the last 2 lines here of code are to get our statistics out of that. So we've specified the model. Now we need the fit statistics. So ottengolf.fit, you can call it whatever you want in the front part of that little statement there, but .fit tells R something. Typically I match up whatever I called .model, and then I call it .fit, the same thing in advance of the dot there both times. But either way, you have some flexibility in what you call it. Okay, so ottengolf.fit equals CFA, that's confirmatory factor analysis. Ottengolf.model, that should match your top line. And then data equals, and then the name of the data set. The last line is where we're going to get our fit statistics. Summary, parentheses, ottengolf.fit. Standardized equals T, that's like you're asking R to get the standardized, in this case, factor loadings and correlations as well between factors. And then the fit.measures equals T, that's where you're going to get your fit statistics from. So I have also intentionally put in a small error in my code that will cause this not to run. So I'm going to let you pause the video, or maybe you already noticed this, to try to detect where my error is. Okay, do you see it? Or maybe you already noticed it. Let me run it. Sometimes R gives us an informative error message. Sometimes it doesn't. This time it said object factor analysis 1 not found. So, and that's what I attempted to name the data set. So it's not finding the data set. And in this case, I have failed to capitalize the F in factor, and it cares about that. So just, lesson learned in terms of capitalization, attention to detail. When we're doing research, we want to be attending to detail, right? Conscientiousness, this is good stuff that we want to exhibit when we're doing psychology research and trying to impress our advisor, right? So that's my pitch for trying to attend to detail here. On the other side of it, R is picky about random things. We just have to go with it sometimes. So anyway, capitalize the F because I capitalized the F in the name of the data set. And let's try it again. Okay, so we've got our data now, or our output, that is, our results in the bottom left. And I'm just going to show you briefly how it matches up to the diagram over here. So I'm going to start with the factor loadings. So you go about halfway up, and it says latent variables, and then the factor loadings are positioned on the right side of the chart here according to each item. And each item is, as we specified in the beginning, each item is assigned to a factor. So, for example, item 1 or CSAI1, that's part of the somatic anxiety factor, and you've got a 0.758, shows up in the diagram as 0.76. For item 4, it's the same, you just go across. This is the std.all column for standardized values, 0.76 for item 4 as well, and then for item 6, it's 0.689, over here in the diagram, 0.69. So you should be able to match those up accordingly here. The correlations between factors are also there, so that's under the covariances section. A correlation is a standardized covariance. So you just look in the standardized column under the covariances section, and you've got 0.795 for the correlation between somatic anxiety and cognitive anxiety, which in the diagram is 0.80, and so on, negative 0.14 for somatic anxiety and confidence. There's 3 of them there. Okay, the other piece of this is the variances section, which will give you the error variances or leftover residuals after each item has been predicted. So those are the ones on the side here. I say predicted. After each item has been assigned to a factor, it's the leftover variance after the factor loading has been accounted for in the model. So the first one, 0.425 for the first item, that's 0.43 over here in the diagram. For item 4, it's 0.417 or 0.42 in the diagram, and so on. Again, you're using the standardized std.all column. And then the last thing I'll show you is actually the first thing that appears in the output, and that is the fit statistics. So we're going to go to model test user model, which is R's strange way of designating the chi-square test. Well, it does say chi-square here in parentheses, so that should help remind you. So we've got a 40.91 for this model, 24 degrees of freedom, and a rejection 0.017 p-value. The comparative fit index CFI 0.976, and the root mean square error of approximation 0.055 RMSEA. So we'll just start you with that. That's a relatively quick confirmatory factor analysis in R. As always, if you have any questions, just do not ask them. No, if you have any questions, please let me know in class. Email me. I'm here.